Hello, thank you. I'm Finnian Anderson. I'm from Suffolk in the UK, and it was my 17th birthday just last week, so I'd like to start off by saying thank you to everyone at Docker for putting on such an amazing birthday party for me. So I'm going to talk about three things really. First of all, I'm going to talk about what the kind of things I did before Docker came into my life, some of the stuff I did with Docker since it came in, and what I plan to do in the future with Docker to achieve fame and fortune. So I'll start off with the things I've been doing before Docker came along. So I started to learn to program with the Raspberry Pi when I was 12. It was a 12th birthday present. I really had absolutely no idea what I was going to do with it, how it worked, or even how to write basic Python program. So I started off making some basic web applications and then moved on to physical hardware things, such as this robot. So this was a robot I built for a project with a couple of friends. The tracked chassis had a live stream camera and lights to show where the driver was going. It had a sensor on the front to make sure that it wasn't going to crash into anything. And it also had a temperature sensor in case it went somewhere it was a bit too hot for it. We learned Python quite extensively and also how to use low-level networking because we built our own protocol on top of TCP so that we could control the robot from anywhere in the world. We also learned how to build an API because my two friends who weren't that familiar with Python, I had to build them a wrapper library so that they could control the robot with various different controllers, such as the Wii remote and also an Xbox controller. During this, we had to learn how to use version control because it turned out that using Dropbox to edit files at the same time was not particularly good way of doing things. And if you think merge conflicts are bad, how about like file conflicts? That's even worse. So we moved on to learning Git, and it was a pretty steep learning curve. Here's an example of a pull request I submitted for a repository back in the day. So I wrote a wrapper for a wrapper, and I thought that was quite cool. So I submitted a PR. Unfortunately, it wasn't cool, and it got closed pretty swiftly. So that's a great example of how not to submit a PR. I also learned that this is kind of bad. No one knows what that commit does, and even I don't know. So putting commit messages that tell everyone what's going on is really useful. I also learned that rewriting history is generally a really bad thing to do and is very, very dangerous. At one point, I had committed a whole load of commits from my Raspberry Pi user, so of course it had the wrong handle on GitHub. I rebased the whole repository to edit all of the authors and accidentally did it twice, pushed to the remote base, and duplicated all of the commits in the repository. That didn't go down so well because it looked like I doubled all of the code I'd written. So moving on from there, I started to move into more web development stuff. So back in 2015 at the YRS Festival of Code, I worked with 6 other young coders to build a revision app, which was built using Node.js. We used open data in order to collect the exam board PDF syllabus for the user, and then it would pull out the keywords from that, and then we threw them at TextRaiser to tell us more about what those words meant. We then used simple Bing searches for those keywords, and then we went on the top articles with the idea that if the internet says it's good content, it must be good content. So we then pulled out the sentences from those articles and then used TextRaiser again to find out the keywords within those, and then we took out those keywords in order to create gap-fill sentences for the user. As part of this, I learned Node.js in about 4 days and how to do very swift collaborative coding in probably the bad way. So the reason for using Docker behind this project in particular was there was lots of different people working on the project, and we had lots of different parts of the app. So if we'd been using local containers and Compose for a database, we'd have been able to make sure that we all were running the same versions of everything, and we didn't have conflicts across each other's systems, and we didn't have it works on my machine. It's happened a lot. So as part of that, we then presented at the Open Data Institute Annual Summit in London. The whole day was about building an app to get people to eat more healthily. So we originally created an app called Healthy, I know, originally named, and it took a user's input for the food they'd eaten and calculated how many minutes of exercise they needed to do doing different activities. So for example, I went on there this morning and I took that pancake that I ate, and it turns out I need to walk around the block for about 20 minutes. So again, very fast-paced development, so collaborative coding and efficient consumption of APIs so that we weren't hitting limits on the food we were using. So why Docker? Well, it was very, very hard to mirror the production environment. At that time, I basically had one medium-sized server and I put all of my apps on it, which meant that there were conflicts between apps all over the place. If we'd used Docker, I could have just shoved it in a container and then used Compose and we'd have all been fine. And when you're trying to present in front of Tim Berners-Lee and get your app running in time, you don't really want to have deployment problems. So if we'd used Docker, that would have been all fine and Docker would have had our back. Then my friends and I, we were bored one weekend, one wet and windy weekend, so we decided we were going to build a URL shortener. So in about 10 minutes, we had our first version of the app deployed, and it was already set up to use custom URLs and ultra-fast redirects. And because we were developing so quickly, we had to make sure that the files we were changing on GitHub weren't conflicted with anyone else's, because if we had merge conflicts, that was going to kill our development flow. So why should we have used Docker? Well, essentially because the app was so tiny and lightweight, it was a bit of overkill to deploy it bare bones on the server. If we put it in a container and just shipped that off, it would have been so much quicker and easier. As I said, we deployed and built it in about 10 minutes, the first version. If we'd used Docker, we could have probably shaved 20% off that time and run it even faster. So now I'm going to talk about the stuff I've done when Docker came into my life. So first of all, I'd like to introduce you to Alex Ellis. Would you like to stand up, Alex, and give everyone a wave? So Alex is a Docker captain, and I spotted one of his blog posts about Raspberry Pi and Docker. And I thought, well, this is cool. So my family has been collecting Raspberry Pis for the past 5 years, and it's about time we did something with them. So I put together a Docker swarm using Alex's video and blog post, which you can see on the link down there. And I had it working in about 2 hours. But the first thing I had to do was decide what I was going to do with it. So I built a very simple Node.js application, which took the container's ID and outputted that to the browser. And I built a monitor to show the load across this cluster and scaled it across all 5 nodes. So it shows the average CPU and memory usage across all of the 5 nodes. I then built a simple program for the PyGlow on top of the Raspberry Pi stack, which shows the load across the cluster as well, just in an LED matrix instead, which is quite cool. So this was about halfway through the benchmark, and we can see that the load's about 50% on the cluster. So now I'm going to talk about a Docker swarm that I have in the cloud right now. And down here, I have a little box with a Raspberry Pi in it and 2 servos on the front with 2 dials. So in real time, we're going to try and demonstrate Docker swarm scaling, and we're going to benchmark it, and you should see the dials move. So I have Cortana here, and you can see I have the 2 instances running. I have one, so if we go down to Swarm, you can see I have the 2 Docker hosts running in the cloud. And then if I go over to services, you can see I have the DockerCon Redis and the DockerCon Web containers running, and they're distributed on the network. So at the minute, the Swarm app node 1, which is the web server, is scaled to 1 instance. So I'm going to go ahead and benchmark that. And you should see the dials move up. There you go. So as you can see, that one's come back with an average request per second of 100. So if I go back to Cortana and scale this up to 2 instances, and then we can go in here. So we should have seen one of them come up. If I go ahead and mark that again, we should see both of the dials move. And you'll see that the request per second will be higher. There we go, 182. So that demonstrates that Docker Swarm is load balancing across both the containers in real time. And we can see it doing it down there on the Raspberry Pi. what's going on here. Ah, there we go. There we go. Okay, so that's demonstrated those three concepts. In the museum, I have a very similar build just outside in the hall. It's got pretty much the similar hardware, except that it's monitoring hashtag DockerCon on Twitter. So we have unique tweeters and tweets. So if we have lots of tweeters but not many tweets, that shows as a high concentration. Really, we want everyone tweeting lots of tweets. So get out there and start tweeting. So another thing that I've been doing with Docker recently is CI and CD pipelines. I expect most of you know what CI and CD is, but just for those of you who don't, CI is continuous integration. It's a way of automating your tests through your code to make sure that that commit you just merged in isn't going to break anything else. Why is it useful? Well, it gives you very good analysis of different scenarios happening to your code. So if you have lots of different things that may happen if a user does certain things, you can check that that's not going to break the rest of your app. What do I use it for? I use it for exactly that, to make sure that my code isn't breaking when I merge new things in. I use it for fleet reach, which I'll talk about later. And so now we're going to move into things I hope to do with Docker in the future. So I run a sailing startup, which we're just building up from the ground. I originally wrote the app in PHP, but it's starting to become a bit unwieldy. So I'm rewriting the whole thing using Node.js and deploying with Docker so that I can rely on Docker to handle everything for me. Very simply, it's a platform for sailors to network and monitor their performance over time and to make sure they can progress and monitor their sailing so that you can see how people are sailing all over the world. And with that, thank you very much. You can find me here and here. And does anyone have any questions? Yes, Mary? Okay, so each container running in the swarm uses Redis, which communicates with the host manager. And then the host has a pub sub directly to the Pi, so it's sending each request as it comes in, so I can adjust the surveys as it comes in. Yeah, I will be publishing my slides for everyone if you would like to see them. Thank you.